the Cosmos product guy. I was the product manager on the Cosmos SDK, the Cosmos Hub, and IBC, as well as Akash, Sommelier, and Noble. And my company, Strangelove, helps build a lot of core technology behind IBC specifically. Next slide. And then just the next couple of slides are a few more projects we work on. Next slide. We validate on around 11 networks right now. You can see them here. Next slide. And here's a few of the different products we've built. The Go Relayer, which is one of the major implementations for the Relayer protocol in IBC. Interchain Test, which is the premier testing framework for IBC. Horcrux, which allows validators to run across multiple machines, broadly used in production across Cosmos chains. The Cosmos Operator, which allows you to run many different Cosmos full nodes. The theme here is a lot of infrastructure level technology. And when you see products like TFM and Skip and Squid, the packet forward middleware that powers all of those came out of Strangelove, as well as a number of other IBC pieces. Next slide. Here's a few of the partners we've worked with over the years. Next slide. So when we're talking about UX and IBC, it's this fundamentally asynchronous construct. And Dean just talked a lot about asynchrony here. But the way that people are talking about this right now is as intents. So as a user, I want to express my intent to go do an action on another chain, and I sign a message, and then that gets processed across any number of other chains. Next slide. So, next slide. So here's kind of a Web 2 kind of cheeky example about intents. You send a web request to Google. Google has a bunch of back-end servers. They send out a lot more messages. They compose those responses and they give them back to the user. This is fundamentally how IBC is meant to work from a user experience standpoint, and it's a world we're quickly moving to. Next slide. So, right now, users have to sign a transaction for every step. I mean, now that packet forward middleware is broadly deployed, they don't, but this was the state of play for a long time. Next slide. So here's an example of how some of these middlewares work in practice. Let's say I have USDC on UMI. Okay, so I have some Atom on Kujira, and I'd like to lend USDC on UMI. Here's the set of transactions that you as a user would have to send to do that. It's about 8 different transactions. It's very complex, and I think when you talked to folks who were really deep into DeFi during the last cycle, this is what they spent a lot of their time doing. Just sending a ton of individual transactions across a bunch of different blockchains. And let's go to the next slide and see how IBC middleware helps make this a lot easier. Next slide. So, middleware, much like web server middleware, adds additional processing as a message is sent. So, next slide. So we do this by adding a simple JSON blob to each token transfer that goes over, and this gets interpreted by the middleware on each individual chain and allows the user to sign once and perform many different actions. Here's a couple examples. So the forward middleware is one that I've talked about. There's also the swap and forward middleware that a lot of DEXs like Duality and Osmosis have, and I'm sure a lot more are going to be deploying soon, that allows you to send tokens in, swap those tokens for another set of tokens, and then forward the resultant tokens to another blockchain. Next slide. So now with IBC middleware, between swap and forward and packet forward middleware, it allows you to take that really complex action that used to take around 8 transactions and bring it into 1 transaction. Next slide. So this allows accounts to control smart contracts on other chains really seamlessly, and it is a key piece of bringing IBC UX to the next step. Next slide. So there's a bunch of more features like middleware that are helping improve IBC user experience. I'm just going to run through a few of them right now. Next slide. IBC hooks. This allows application developers to write callbacks. So when an IBC packet gets sent, there's an acknowledgement that comes back, and the hooks allow developers to process that acknowledgement and do additional processing after the acknowledgement is received. Next slide. Swap and forward middleware, which we just covered, is around trading and helping enable other use cases there. Next slide. NFT transfers. There's a new NFT transfer protocol, ICS 721, that's been built by the Stargaze team and the Cosmospehere team that's going to be coming to market soon. This will allow you to move your NFTs across IBC. Next slide. Atomic swaps and interchain liquidity. The Slide team has built a protocol where you can send an IBC message that actually just creates a bid on one chain, and then somebody can send an IBC message from another chain to accept that bid. And what this in effect allows is atomic swaps. So if I have Atom and I want to swap it for osmosis directly without going through a decentralized exchange, I can use the Slide protocol to do that. I don't know if this one's going to get used a whole ton in production, but it is a really interesting proof of concept showing more complex interactions. Next slide. The way that we need to start thinking about middleware is exposing an interchain API. So if you're an application like a lending protocol, you would want a middleware that allows users to send tokens in, borrow against your lending protocol, and then send those resultant tokens out. And this is a way where sort of arbitrary applications like derivatives protocols or perpetuals protocols can expose their functionality in a way that improves user experience in the interchain and allows users to make these complex multi-chain flows easy. Next slide. Here at Strangelove, we also spend a lot of time expanding on IBC. So we've been working with the Composable team, all of the teams bringing IBC to Ethereum, the teams bringing IBC over to Avalanche, as well as a number of other folks like Penumbra to help expand IBC beyond its core in Cosmos. We believe that IBC as a set of specifications is the right way to enable interoperability across many different ecosystems. And as somebody asked earlier, even enable interactions like IBC from Solana to Ethereum, which I personally believe is going to be amazing when it happens. Next slide. So, one way we can help grow IBC beyond just creating these light clients is to help bridge providers be able to integrate IBC a lot easier. So, with some of these more advanced networks and all of the different IBC to Ethereum connections, there's required changes to the Cosmos SDK and the lower layers of the stack that necessitate sort of an individual blockchain that helps intermediate those interactions. Think of these as kind of committee-based solutions. This is very similar to what Wormhole does, what Hyperlane does, what Axelar does. We believe that developers should be able to use each of these different committees to send IBC messages. And we're planning to build wrapper contracts around these different blockchains to help developers anywhere where Wormhole goes to use IBC easily. We think this is a great way to expand the IBC transport layer to the broader swath of to the broader swath of blockchain developers out there, and show them the power of the generalized message passing protocol that IBC is. When I've been at Zampolin, the team there has been building these vaults over on Ethereum, and we've recently started using Axelar as a bridge. Axelar is a fantastic product, but in terms of building complex call and response protocols that require a deeper level of interoperability, you've got to end up rebuilding a lot of the things like acknowledgements and hooks that IBC already has out of the box. And we think that this is going to be a great way for those bridges to help expand their distribution and also for IBC to help expand their distribution. Next slide. Generalizing IBC is another key feature this year. Currently, IBC Go is heavily tied to the Cosmos SDK, and it's hard to use it in other Go environments. There are stacks like Optimism and Avalanche that are all built in Go, and if we remove the Cosmos-specific pieces from IBC Go, we could use it in these other environments. This is a key piece of work that's going to be happening over the next year. Next slide. All right, well, thank you very much. Tried to keep it short as a lot of the other talks went long. If anyone has any questions about IBC, happy to answer those right now.
Yeah. Hey. Oh, okay. If we have any question, please raise your hand. Yeah. Okay, everyone understand it very well, yeah? Thank you so much.
Thank you guys very much.